All right, let's finish up. So, if we're going to explore parallel and perpendicular lines, it's important that you understand that has something to do with slope. So, I have a pair of blue lines, y equals 2x minus 3 and y equals 2x plus 4, a pair of pink lines, and a pair of green lines. So you can see that I plugged them in on my graphing calculator, and I took a picture so you could see them inserted in the Y1, Y2, Y3, Y4, Y5, and Y6. And then I graphed them, and I put my zoom 6, which centers my screen on the X and Y axes, and zoom 5, which makes it look square. Well, do you see that the pair of blue lines is parallel, the pair of pink lines is parallel, and the pair of green lines is parallel? Well, what is true about the slopes of the blue lines? Well, on the blue lines, the slopes are both m equals 2, and the blue lines turned out parallel. On the pair of pink lines, the slopes were both m equals -4, and the lines turned out parallel. And the same kind of thing on the green lines. The slopes were both m equals 2/5. So I'm trying to see if you remember that whenever two lines have the same slope, the two lines turn out to be parallel when you graph them. Well, we could do a similar exploration for parallel and perpendicular lines. So here my blue lines have slopes of m equals 2 and m equals -1/2. Well, when I graphed those and took a picture of it for you, how would you describe the lines? Well, they look like to me they're crossing at right angles. That makes them perpendicular. Pink lines are the same idea. If I look at the slope of my first pink line, it's 1/4. The slope of my second pink line is -4. Well, the pink lines also turned out to be perpendicular when I graphed them on the graphing calculator. And the green lines had slopes of 2/5 and -5/2. So what would you say is true about the two blue slopes? Do you see that they are both reciprocals and opposite in sign? Well, do you see on the slopes of the two pink lines, 1/4 and -4, are also reciprocals and opposite signs? So do you see I'm talking about slopes that are opposite reciprocals? So look at my green slopes. 2/5 and -5/2 are again opposite reciprocals. So I'm trying to remind you, if your slopes are opposite reciprocals, then your lines are perpendicular. So if I apply the two things I've learned earlier today, notice that I'm giving you an equation of a line that's in ax plus by equals c form, that standard form. What's the slope of that line? Well, if I use the new formula -a over b that we talked about earlier, -a is -3, b is -5, that's 3/5. Well, now I'm asking you to tell me, what do you know about the slope of a line that's parallel? Well, I like to call this the parallel line slope. Well, we just went over the fact that parallel lines have the same slope. So any parallel line would also have a slope of 3/5. Okay, so what's the slope of this line that I'm giving you in slope-intercept form? Well, are you looking at it and saying, well, the slope is 8/3? That's a pretty easy problem there. Well, this time I'm asking you, what's the slope of a line that's perpendicular to the one I gave you? Well, I like to call this the perpendicular line's slope. Well, we just said the slopes of two perpendicular lines are opposites and reciprocals. Well, the green slope is positive, so my red slope should be negative, so they're opposite signs. And then 8/3 reciprocal is 3/8. Now my two slopes are opposites and reciprocals. So let's summarize our big ideas. All pairs of lines are either going to be parallel and have the same slope, or the lines are going to be perpendicular and have slopes that are opposites and reciprocals, or the lines will just intersect each other, but they won't intersect each other at right angles. In this case, the slopes are neither parallel or the slopes are neither the same nor opposite reciprocals. So again, you could have parallel lines, you could have perpendicular lines, or lines that intersect but they're not parallel or perpendicular might be like this. Two lines that rise could intersect, but they won't intersect at right angles. You can see that these angles look like they're acute, and these angles look like they're obtuse, so they're not intersecting at right angles. That means their slopes aren't going to be opposites and reciprocals, and they're not going to be the same. Okay, so knowing that, I could ask you, are the pairs of lines that I'm giving you parallel or perpendicular or just intersecting? Well, guys, to answer this question, you have to know the parallel perpendicular question is a slope question. So you need to go through and tell me the slope of each line. Well, for line 1, since line 1 is in y equals mx plus b, the slope of line 1 is just 3/4. Well, what's the slope of line 2? Well, it's also in y equals mx plus b form. So the slope I can just look at and say is 4/3. Well, guys, are those the same slope? No. Are they opposite reciprocals? No, they're just reciprocals. So if they're not the same and they're not opposite reciprocals, that means they're just sort of, two different slopes, which means that I would say line 1 intersects line 2, but they don't intersect each other at right angles. So line 1 intersects line 2 is your answer. Now on this one, I'm going to do the same kind of thing. Are the two lines going to intersect, or are they going to be parallel perpendicular? Well, again, I need to look at line 3. Line 3 is given in y equals mx plus b form, so you can just name the slope right off the bat. Line 4 is not given in y equals mx plus b form. Guys, this is standard form, so it's ax plus by equals c. So the slope is negative a over b. And that reduces to positive 1/2. All right, so I've got my information. Now I need to interpret it. Are my slopes that I wound up with the same? No. So the lines can't be parallel. Are they opposite and reciprocal? Yes, they are opposite reciprocals. So I now know my two lines are perpendicular. So my answer is that line 3 is perpendicular to line 4. And notice I'm using the symbols for parallel and perpendicular because it's a little faster than writing out the words. So last but not least, same kind of question. Well, I need to say that line 5 has a slope of 13/4, which I can see just from the fact that it's in y equals mx plus b form. Line 6, I'm going to have to do some work. So earlier we said if you're going to do this quickly, sketch the point 0.8, which would be way up here on the y-axis. Sketch the point -4, -5, which would have to go left 4, down 5. Oh, so I see that my line is diagonal and it increases, so my slope is positive. Now remember, rise means count the spaces between the y's. So do you all see that from 8 to -5, I would have to count 13 spaces. From -5 to 8, I would also count 13 spaces. So which way you count doesn't matter. Run means count your x's. So from 0 to -4 or -4 to 0, I get 4 spaces. Now I have enough information to interpret. The slope of the first line was 13/4. The slope of the second line is 13/4. Those are the same, so I automatically know that line 5 is parallel to line 6. So I just put the parallel to symbol in between. All right, so earlier we worked on converting from standard form to slope-intercept form. We're going to go the other way as well, and then we'll be done with this lesson. So remember, if I've got right now, this is standard form on number 1. I want to go to slope-intercept form. That means I want y equals mx plus b, because it says convert to slope-intercept. Okay, so guys, that means I've got to isolate y. So when I do, just like I did earlier, I'm going to subtract 8x to the other side. I'm going to divide everything by 12. When I do that, I need to separate and reduce. So I see that -8 over 12, 4 goes into both, would become -2 over 3x minus, because -20 over 12 would be negative, 4 goes into both again, 4 goes into 20, 4 goes into 12. All right? So that's pretty easy. You've done those before. All right, so this time I want to convert to standard form. So that means I want ax plus by equals c form. So notice that means the x's and the y's are on the left, the plain numbers on the right. Well, that means I need to move the 4x to the left, so I'm going to subtract it to the left. I'm not supposed to have fractions in standard form, and I don't, okay? So one possible answer is my red answer, and you can leave it right like that. But I do need to mention to you, some teachers don't like the x part to be negative. So what you can do is you can multiply the whole equation by negative so that you have positive 4x, negative 1y, and -6. So there's really two versions of standard form which are correct. I would always accept either one that you were to put on the homework or quiz or test. All right, so let's do this last problem the same way. So I want ax plus by equals c form. That means I want my x's and my y's on the left. So take the 3/5 x and move it to the left by subtracting. So that gives me -3/5 x plus y and -7 still on the right-hand side. So you can get rid of the negative if you want on front of the x, or you don't have to. On this one, the difference, though, that I'm going to show you is I'm not supposed to have fractions in standard form, so I need to clear my fractions. That means I'm going to multiply everything by 5. You could also multiply by -5 if you didn't want to have a negative lead. That means I'm going to say 5 times -3/5 x. I'm going to put that 5 over 1 here, plus 5 times the y equals 5 times the -7. So I'm multiplying all three terms by 5. What happens is I wind up with -3x, and then 5 times y is just 5y, and 5 times -7 is -35. Now I've got an answer for standard form that works. Because remember, standard form not only has x's and y's on the left, plain numbers on right, it also has no fractions. So guys, you are ready to finish the slope worksheet. I'm pausing so the last page shows up, but there you go. You can finish this worksheet.